My name is Wendelin. Several years ago, my first contribution to Gradle, I created the original JavaScript, CSS, and Digest plugins back in 2008. Fast forward to today, I joined Gradle about a year ago, and I think several months ago, I now lead the Build Tool core team. I'm a dad and husband. I have a little girl, Freya. She's awesome. In the JavaScript world, I created a suite of tools for generating, parsing, enhancing, and reporting JavaScript stack traces called StackTrace.js. You can check out. You'll see one of the tools here later. Before I get into the technical bit of the talk, I want to explain why I chose this topic. We like to make data-driven decisions at Gradle, and one of the best tools that we have to do that now is Google's BigQuery GitHub repositories. So some months ago, I was researching how users are using Gradle, at least through their open source stuff on GitHub, and I found something very surprising. I found that in terms of source bytes, that is like the files that not distributed, it's the fourth most built in sources. JavaScript is the fourth most built language. And the fifth most built is HTML, and the sixth is CSS. And if you put all of these together, it takes up 13% of all of the sources built by Gradle are for web assets. And I found this really surprising and made me think, I think we have some good justification for investing here now, especially with some of the features that we've developed in Gradle 3.5 and 4.0. I want to note how valuable, and I want to give a shout out to the Google Cloud Platform team for how valuable the BigQuery GitHub data is, both GitHub Archive and the public data, because they're two separate things. The GitHub repos data has information about files, small files content, repositories, and languages. And you can reproduce the results that I just showed you in this chart at this short link. And I'll, of course, be sharing the slides after this talk. OK, so I have three main things to talk to you about today. I want to give you a little bit of the state of the union, where we're at, and where we're going. I want to show you examples for how you can orchestrate your JavaScript tools with Gradle and take advantage of Gradle's unique features. And I want to tell you a little bit about the trade-offs and considerations for doing so. I want to first note that the target audience for this is primarily developers of Java-backed web applications. And the reason being is that they're most likely to already be using Gradle, so the cost of investment is lower. But of course, they have to be building web stuff, or this talk wouldn't be worthwhile. So, where are we today? The JavaScript ecosystem is, of course, moving very fast. Just in the last year, Webpack has emerged, I think, as a clear winner for bundling not just JavaScript, but CSS, transpiling TypeScript, and all sorts of other stuff into separate bundles so they can be distributed. There's pretty fierce framework competition between React and Vue and Next.js and isomorphic JavaScript and all sorts of like Polymer. And there's really no clear winner here. And so because there's no way I could really advise you on common scenarios, I'm going to try to keep my guidance mostly generic so that it hopefully applies to the broadest audience today. But I'm happy to try to answer more specific questions in the web Slack channel, or if you hit me up on Twitter or whatever. And of course, I don't know all the JavaScript frameworks because that's impossible. But I can try my best. Progressive web applications is a concept for essentially offline first or installable web applications. They achieve this through a new technology in browsers called service workers that allow them to basically compete with technologies like Android and iOS, where you really have the app right there on the web. And finally, in the last year, Yarn and NPM version 5 have made major steps forward in JavaScript dependency management through NPM. They introduce tools that make JavaScript dependency management faster and more deterministic. So if you're not using these two with your node libraries, I highly recommend it over the alternatives. I guess I would say there's 3 common build paradigms for managing web assets. You could go full on Java, where JVM tools manage everything. Tools in this arena are like Google Closure Compiler, the YUI tools, and the Gradle JavaScript plugin. This allows organizations who choose this methodology to reduce the total technology set at the expense of tool choice. So you only have a few tools, and they're rapidly becoming out of date because the industry seems to have shifted to invest exclusively in JavaScript. One example we have for this is the Google Closure Compiler was recently ported to JavaScript from Java. Or you could go the complete opposite. Full-on JavaScript, have completely separate web builds and your server-side builds. This can give you the best of each individual world, but integration may be tougher. You have 2 separate build processes. There's tension there, organizationally and through the tools. And finally, a hybrid where Gradle can orchestrate JavaScript tools themselves. And that's what I hope to focus on today, and to make easier and more automatable through examples, docs, guides, and of course this talk. So let's talk a little bit more about orchestrating Node.js tools with Gradle. Okay, so these are the sort of more obvious opportunities from things that you saw in the keynote that Gradle can bring to building web applications. I'll explain the 3 of these and how Gradle can generally be used to solve them. Heterogeneous environments, you can think of as if you have a diverse set of machines that are trying to run your code. Things might be less deterministic. The whole like works on my machine kind of thing comes from this. It's of course not specific to web development, but I do have a couple of specific parts of guidance for those of you who have this kind of problem. Chances are that if you're serious about environment isolation, you're using a container like Docker containers. And I highly recommend that you use the official Docker repository up on Docker Hub. It has all the Gradle versions back to like 0.8 or something like that, and lots of JDK options, including Java 9. And in containerized environments is where the build cache really shines, especially when the remote cache is in play, because it doesn't have to build a lot of the stuff locally. It can fetch those from a remote cache. Now, you can provision Node and NPM and Yarn through Docker, but provisioning Node through Gradle, a Gradle tool, will allow you to run the same build with more consistency outside of Docker and inside Docker. And for that, I recommend the use of the Gradle Node plugin. Now, the Gradle Node plugin is something that can not only manage your Node and NPM and Yarn versions and manage those Node dependencies. It can run Node scripts and a whole bunch of other stuff that you'll hear about from Sten tomorrow morning. So I highly recommend it, and I expect that we will try to invest in the Node plugin in the future. You can learn more on the Docker Hub Gradle page. For Docker itself, I recommend the Gradle Docker plugin from Ben Mushko. And there is a Docker talk tomorrow at this time if you're interested in this type of topic. Similarly, I highly recommend the use of the Gradle Node plugin. I feel like that's the future of where we'd like to invest. I wouldn't expect that we would have native support for resolving Node modules in Gradle soon without a shift in the industry or a major open source investment. So we're going to try to work with Sten to make the Node plugin even better. And you can hear him talk about this plugin tomorrow morning at 10. Okay, so one of the biggest problems with using web tools to build web assets today is that it does a lot of unnecessary reprocessing of assets. It does this because it makes no assumptions about what the developer has done. It doesn't really track inputs or outputs. And so things like incremental builds, are only a thing in watch mode, I think. And so, rebundling and repackaging and transpiling your assets is a cost that can grow kind of silently unless you're tracking it. You start adding source maps, and you start adding uglify and TypeScript, and you add more sources and tests, and all of a sudden you have a several minute web build, and it can be a bottleneck for your whole application. So I want to show you a simple way of writing an ad hoc task for delegating to Webpack from Gradle, but then also adding the Gradle's goodness on top. Oh, I need to mirror. 1 second. Okay. Can everyone see that okay in the back? Okay. Now what I have here is a Grails app that I just created with Grails Create app with the Webpack profile. And that gives me a quick Hello World app that has both a Webpack component to it, a separate Webpack component. And that build comes with, if you were to generate it today, it comes with a bundle task that actually it uses the Gradle Node plugin under the hood. And so, for example, if we want to run a Gradle bundle, this is a yarn task that delegates to Webpack. And you can see here at the bottom, I don't know, actually, let me see if I can load this up for you a little bit. It executed Webpack, okay, as expected. That's fine. But if we run it again, it rebundles, even though I changed nothing, right? And this could be extremely expensive if you're trying to change something unrelated to your web code. So we can use Gradle's incremental build here. So instead of using a yarn task, for now, let's just use a plain exec task. And what we need here to just execute, we want to execute Webpack. And we declare our inputs and outputs. So our sources are the Webpack config, package.json, yarn lock file, and everything in our web app directory. And we're going to produce one bundle, bundle.js. We figured that out from our Webpack config file. Okay. So now we have an incremental ad hoc task. I can say Gradle incr bundle. Okay, so it executes the task. And making no changes, I execute it, and it's up to date. I'm sorry, was it up to date before? Oh, it was all up to date. Yes, as expected, because I executed it. If I remove the bundle file and execute it, then it will not be up to date, or it should not be up to date. Ah, there's a bug. Outputs.file. That's bundle.js is not a directory. All right. My mistake, folks. This is why I need to turn on build scans, but I turned it off because I was afraid that the network would prevent my demos from running. And so it's sort of a catch-22. Yeah, Sterling knows it, I'm sure. But
I can only see like half of this.
Oh, got it. No problemo. Yeah, I'll look into this. I'm pretty sure that if I remove it, I know it. Yes. So I must have messed this up without. Okay, that's what it is. It's the wrong file. It's in a different place. Okay, now it executed it. Sorry about that, folks. This is why Kotlin and everything will help us out a whole lot. It can inspect our build directories and tell me, hey, that's not a real file. Okay, so we have an incremental task. Now let's leverage the build cache. All we need to do to leverage the build cache is add this outputs cache if true, and that will always use the build cache. Yeah, that will always use the build cache, but it won't work with remote builds. We need to declare path sensitivity to make that happen. So if I remove this once again, and I run Gradle cacheable bundle, it should execute Webpack. Oh, it's in my cache. So I didn't clear my cache, but you can see here that if I would make a change to the sources in source main web app, and re-execute, we see it executed, and then it was up to date. Didn't need to get it from the cache. It's already there. So if I remove it, then we'll get it from the cache. Okay, great. So through a bunch of effort, we've successfully wrapped Webpack and added incremental build and remote cache capability, or sorry, local cache capability, build cache capability. Now this is ad hoc tasks are cumbersome to develop sometimes, and we wouldn't want to do this for every single one. A custom task, an ad hoc task, of course. And so for that, we of course recommend the use of custom tasks because they're more testable, distributable, and among other benefits. So I'm going to go ahead and show you an example. Let's see if I can blow this up a little bit. So this is a custom task that to replace our ad hoc tasks. It extends source task, and that allows us to declare our sources. It uses the cacheable task annotation to say, hey, you can cache outputs here. And the inputs are an executable, optional arguments, a destination file or destination directory, optionally. This is up on a gist. Here's the link. It's available right here if you want to follow along. Now we can throw that into our build script or into a custom plugin and call it, and we just declare our sources, our destination, and the executable. And we have a nice generic task for executing Webpack. So I can say Gradle exec Webpack. And my suspicion, yep, gotta stop forgetting the build cache. It's up to date. If I make some kind of change to it or remove it, and I execute through the build cache, okay, that first time it was cached. And again, oh, up to date. Yep. That's why we have the, okay. So we've successfully loaded our Webpack bundle from the cache. So that's an example of a custom task that you can use to wrap Webpack. But we can also use it for gulp. So for example, here I have one of my stack trace JS projects called error stack parser. It has a gulp build. And I can declare a task of type node exec, just the same as Webpack. I say, well, the sources are my main JavaScript file, package.json, and everything's going to go into the dist directory. We're going to be invoking gulp dist. Okay, so I can say Gradle gulp. It executed dist, and now if I look in here, there's my minified JavaScript. Great. And of course, if I run it again with the build cache, or having removed it or making a change, see if I do Gradle clean, gulp, build cache, then you can see here that it actually resolved the distribution from the cache. What else can we do? I mean, these two look familiar. All you really need for many tasks is to just declare these things. And this is not all we can do with Gradle. If we did add a little bit more smartness to this task, we could probably infer the executable. We might be able to infer some of the sources or destination directory. Or we could have some generic ones that make assumptions like, oh, I know this is a React app, so I know my sources are in the app directory. Or I see there's a package.json or a package.json lock. I can actually parse the package.json lock file. Package lock.json file. And you can add some more smartness. This is exactly the kind of thing that we wanted to build and do for Node. Provide a generic set of tasks to make this easier. add some guides, and then add more specific tasks. Ask you guys to help us, build tasks for Vue or whatever. But this is where we start. Okay, so now we're able to avoid reprocessing assets after no changes. Now let's see if we can make it incremental, so that if only a few sources change, we only reprocess those sources. And we can do that with incremental tasks in Gradle. Now here's some tasks that could theoretically be incremental. Linters like ESLint and TSLint, minification, compression, some transpilers, Babel, Sass, and so forth, executing tests. However, writing incremental tasks is difficult at this point. Let's just say it takes more investment. You have to know what you're doing. But it's certainly worth the investment, especially if you have a very large number of web assets. But it's not something that you can just crank out in an hour. So I wanted to give you an example of, here's part of an incremental node exec task that would be essentially a template for incremental tasks that you might want to write. Okay, so we see it extends node exec. In this case, I enforce that there's a destination output directory. It doesn't really make sense to have like one output file for an incremental task, because incrementality is at a file level. And I won't read the code. The important bit here is that we delete the outputs if for modified and removed files, and then in this out-of-date block, we actually call project.exec here with to invoke our linter or whatever with the specific arguments with that file detail. So, for example, if you want to run tslint on a TypeScript file incrementally, you could say, hey, TypeScript, tslint, only invoke it on this file. Now, of course, tslint is a bad example because TypeScript itself, it requires the use of the TypeScript incremental compiler. However, However, many organizations will go for a mostly correct version of some incremental tasks. So, for example, if you have a tslint task that only lints the files that were just changed, maybe that's okay. Like it catches most of your bugs, and then you might have a full build that does the full linting. Same thing with Sass. Sometimes changes to files are not incremental, but most of the time you can just change one Sass file and you get one CSS file. Let's see here. Okay. Continuous build in Gradle really shines here because it's it's constantly watching for changes to inputs. And so, as Hans noted in the keynote, this is something that you'll want to try using more often, and especially useful when rebuilding web assets if you want a live reload type experience. Okay, one moment. I'm going to unmirror my screen. Okay. Let's talk about the trade-offs and considerations should you be interested in something like this. The general guidance I would have for you is don't miss out on benefits from JavaScript tools. Leverage NPM version 5 or Yarn for dependency management. Check in those lock files and use them in your inputs. They're important sources, and yeah. And then keep your Webpack and Gulp builds, but orchestrate them with Gradle and add that nice layer on top. Specific things for Webpack. If you're using Webpack, I recommend the use of the DLL chunk plugin. This gives a developer finer grained control of the chunks that are output. And along with that, using fixed dependency versions. The benefit of this is that you can have your vendor JavaScript change very infrequently, and you rebuild that very infrequently, and have your own first-party sources. Those can change rapidly and will recompile quickly. Things to think about if you want to use the build cache. I'm sure you can learn more from all my Gradle colleagues, like pretty much every talk that they give at the conference, because the build cache is so awesome and pervasive. But it shouldn't be enabled blindly. You have to. I would recommend that you read this the using build cache guide on Gradle Guides. It's a very worthwhile read if you want to use it. So things that are specific to the web, tasks that link to native libraries are environment specific. So if you say run CI on using Linux and you push to a cache instance, but then you have a Windows or Mac machine, and it's going to link different libraries, and so that what you resolve from the cache isn't going to work. Similarly, in node modules, it's common for node modules to use symlinks, and those symlinks are links to files that contain relative references to their other files. And unfortunately, because of the way we inline those symlinks in the build cache, that actually breaks the symlink, and those no longer resolve. And sometimes it's actually faster to rebuild something than to reuse it. And I think that's something that is considered for automatically for a new version of Gradle. So profile, people. Now let's talk a little bit about some trade-offs of this whole idea. If you just have a JavaScript build using JavaScript tools, JavaScript tools are going to have slightly lower overhead for web-related stuff. There's connecting to the daemon, all that stuff is cheap, but it's not free yet. We're keen to eliminate configuration time. Currently, there's no hand-holding for this stuff, and so you have to have a deep problem and be willing to invest in order to get that payoff. And finally, the whole organization can benefit from unified tools, basically using Gradle for your front-end and back-end builds, especially if you have the rich build history available from Gradle Enterprise. Okay, so from my side, in my mind, the short-term priorities are make it easier for users to take advantage of unique Gradle features like incremental builds, incremental tasks, and the build cache. We do this by investing in the Gradle node plugin, developing better docs and guides, and integrating more JavaScript-specific features into build scans. And of course, we want to more thoroughly research pain and opportunity with your help. And that's why I need your feedback. In summary, if you use Gradle to orchestrate your processing your web assets, you can gain the advantage of work avoidance using incremental builds, incremental tasks, and the build cache. You can unify front-end and back-end build processes into one process that works well for everyone. And you can take advantage of a rich build history that gives you organizational velocity. Now, this requires an initial investment, and some things are tricky to implement in robust ways, and so they require rigorous engineering. And it's not practical for some project types. If you have a small node library, is it really worth the overhead? Probably not. If you have an isomorphic JavaScript app, debatable. It might require more investment than it's worth initially. But what I will say is that we want to make it easier so that the level of investment is lower, and then it makes it much more worthwhile. So consider your projects. You're more likely to benefit if your project is larger, you already use Gradle, and you can adopt the latest versions of Gradle or Node.js. Of course, a key part of this is the use of the build cache. And of course, if you have one of the aforementioned problems, obviously if you don't have any problems with it right now, measure, and then carefully consider your next course of action. As I said, I need your help for this because the JavaScript community is so diverse. There's so many frameworks and everything. And so as we develop examples, I highly encourage you to write your own example tasks. Write your own variant of a node exec task, invoking your favorite node tool. Or you could write or improve a Gradle guide. This is a link to a JavaScript topical guide that is in progress by me. I would love your ideas, your specific ideas for things to include in that guide, or things that need to be adjusted. File issues for the Gradle node plugin. I think we want to do some more investments here and make those tasks hashable and more generic. And I'm very happy to answer questions or get your specific suggestions in the web Slack channel for the Gradle Summit. And with that, that's all the information I have